ratio and equations. Now it might be me, but I think this is really quite difficult. So here's my question. I've got some blue counters and some red counters. Don't know how many I've got of each, but I do know I've got them in the ratio of 2 to 3. So for every 2 blue, I've got 3 red. Now I'm saying that you can go from here to this, where I've set up an equation. Okay, so what I'm doing here is I'm dividing, if you like, both parts by red, which means I would do the same here, divide both parts by red. So I'm dividing by 3. And then I'm saying that that divided by that is the same, is equal to that divided by that. And then you get the opportunity now to set up an equation. So we could times both sides by 3, which means that 3 will disappear and you'll get a 3 here. Here it is. Times both sides by red, that red would disappear and you end up with here. So we're saying that 3 times the blue counters will be the same as 2 times the red counters. Okay, now I think that's really tough to get your head around. Let's see if this helps with a little picture. So we've got our blue and our red. So we know the ratio is 2 to 3, blue to red. And what we're saying down here is if we times the blue by 3 and the red by 2, they are equal. And you can see now why that works. Times this lot by 3, and you'll get 6 of them. Times this lot by 2, and you'll get 6 of them. And obviously 6 equals 6. So using this idea of having a ratio and setting up an equation is then really useful at solving other problems. So let's have a look at another problem. So again, I've already sort of set it up. I'm just going to talk you through it. So blue counters to red counters, this time 2 to 5. So for every 2 blue, you would get 5 red. So I'm dividing by the red, and as I'm doing the same to both, I'm saying they are now equal. So blue over red is the same as 2 over 5. Times both sides by 5, that disappears, which means you get a 5 here. Times both sides by red, the red would disappear, and you get a red here. So now we have a connection that 5 times the blue counters is the same as 2 times the red counters. Let's see it as a picture. So we had a ratio of 2 to 5, there we go, 2 to 5. If I times that by 5, which is what we said down here, it's this, and times this by 2, they are equal to each other because here I would have 10 counters and here I would also have 10 counters. Okay, so here's another unusual problem, and again quite a tricky one. I'm going to try a slightly different approach. So we've got the ratio of 5 to 3, so for every 5 men you've got 3 women. Well, what happens if I say it's 5x to 3x? So it doesn't change anything. The ratio is still the same, because if you simplified this ratio, the x's would disappear, and you get back to here. Now, this is why I do this. You're told 6 women join the club. Okay, 6 extra women join the club. So you've now got that. Okay, so because we did have 3x, well, 6 extra women have joined up, and the ratio now increases by 40%. No, sorry, the ratio now is for the women is 40%. So men to women is 40%. So you've sort of got 40% here. So men must be 60%. So we could do a little bit of cancelling. And what's that? 3 to 2. Okay. So now for every 3 men, you get 2 women. Now I want to use something that we did before. Yeah. So using our previous sort of skills. So we could say that 5x over 3x plus 6 is the same as 3 over 2. Okay, so using that idea that we had with our counters, where they gone kind of up here. Yeah, so we had this ratio and this ratio. We form this equation. I'm doing the same technique on this really tricky problem. I just slipped in this x because I needed a variable. Okay, so now this is nothing to do with the ratio. This is about algebraic equations. And what we say is, let's get rid of the 2. So we'd multiply both sides by 2. So we've got 2 times this. And this is divided by 3x plus 6. That needs to disappear, so let's times both sides by it and it will disappear. Using inverse operations, that's why it goes. Pop it in brackets. Expand out. Multiply your brackets. Take 9x from both sides. Alright, so now you've got x is equal to 18. What was the question? How many people were in the club before the women joined? Well, that's this bit here. This is the total, 8x. So if x is 18, then 8 times 18 gives me 80, 8 is 64, 144, and that's your answer. Okay, I think that's a really tricky problem, but using the earlier sort of skills of comparing this ratio and this ratio, and knowing that they're the same, this ratio and this ratio, knowing that they're the same, you can set up this equation.